And here we are in the main loop, just like I said before. While running, this is what's going to happen. So the first thing we do is we get user input. So for every event in pygame.event.get, so this returns a list of everything that's happened in the game. It checks and says, if the event is a key being pressed, and if that event key equals escape, we're going to change running to false. So that sets up the ability, while the game is running, if I press escape, it turns the game off, quits the game. That's all it does. If event type is quit, meaning I close the window, then we change the game running to false. Why? Because if I don't do this, the game will continue to run in the background even if the window is closed. So we want to, it's a memory management, cleaning up after yourself kind of a thing. Now, if the event type is add enemy, remember every 250 milliseconds, we are adding an event called add enemy to the events list. So every time we have that happen, triggered, it becomes part of that events list. And if the event type is add enemy, if it's saying it's time to add an enemy, then we're creating a new enemy of the type enemy based on that class that we created. And we're adding that to enemies, and we're adding that to all sprites. Okay, so now we are getting all of the keys that are pressed and putting them into a collection called pressed keys. And we are passing that pressed keys list to player.update. The reason for that is, if we come back up here to player, okay, look at update takes that as an argument. Takes pressed keys as an argument, and then it uses that to determine which keys are being pressed and how to behave. Okay, so that's where that's going. So we press the keys. There we are. So we get the keys that are pressed. We pass them to player.update directly into that method. And then we call enemies.update. So we are updating. We update the player sprite first, and then look at all of the enemies that we're using. That whole group .update. It calls update on all of the things in that group. So if we have 1,000 enemies on screen, one line triggers that same thing for all of them. Really, really easy. Now we're starting to draw the screen. So the first thing we do is we fill it with that blue background color. And then for each entity in all sprites, we're using iteration here for all sprites, because we can't do a blit with each one, but we can do it this way. So we do entity in all sprites, screen.blit, entity.surface, entity.rectangle. Again, how it looks and where it is. That's it. So each sprite is being drawn onto the screen in the background. Next, we're checking for collisions. Okay, so in this one, we've got pygame.sprite collide any. So if the player collides with any of the anything in the group enemies, then we do this: player.kill, running equals false. The game ends. If we were more exciting, this is where we might lose a life or explode or something. In this case, it's just a simple, the game ends, right? And then finally, once we have all of those checks done, we flip the display, and then we wait. And clock.tick, this number represents the number of frames of cycles per second that it allows. So this will wait whatever the time is appropriate based on the processor you have and the speed of running, so that this allows 30 game loops per second. That's on the low end. Most of our console games are running closer to 100 frames per second. A professional level computer-based FPS game you always want to be hitting like at least 120 frames per second for accuracy. But in a game like this is another basic measure of difficulty, because if I run this at 30 frames per second, it looks like this. If I run this at 60 frames per second, it's much faster. Actually, this is just a little bit more exciting, right? So, what's that? Do 100? That's the frame rate of the game. Oh, already lost. Okay, let's see if I can do better this time, huh? Oh. Yeah, this is exciting. This is the most exciting.